Dark matter is matter with no electrons. That is the proposed theory for today's little lecture here. So as we can see in the periodic table of the elements here, these are the same nuclei, the protons and neutrons, the same as for ordinary matter, and there's no electrons in this picture, so it's appropriate for either one. So now the carbon over here has the cube in the center in red, and iron is special. It has a cube of 3 by 3 by 3 here, and that's dark matter. It's ordinary matter with no electrons, so it can't give off any photons, and it can't absorb any photons because there's no electrons paired with the protons. Now, one of the important parts of this idea is that the pairing between the proton and the electron is very important. So that let's get the picture going here of the pairing of all things in the universe for one proton and one electron. So here we see that the proton in blue has 3 dimensions of space coming into it for gravity, and it has 1 dimension going out. Time is going out of the proton. Now the electron is paired with 1 proton. This is in the proposed theory. So, but it only has 2 space dimensions. These 2 red lines here make kind of a membrane between that has a counterflow of another dimension that's called magnet time. So that it's similar to the 4-dimensional space here for gravity. The electromagnetic and atomic spaces in this 8-dimensional theory have the final dimension going to the neutron. That's the sharing that goes on here. And the neutron powers are rotational. Now, I'd like to move into just why the pairing is important, because in this diagram here on the top left, we see that a proton is paired with an electron. And dark matter is where there's no electron at all. Now, when a photon is emitted in the middle here, we see that it's just 2 dimensions out of the 3 dimensions that are pairing, as I explained previously. So it's EX and HT. In a red loop there, this photon is the little fraction or fragment of EX and HT dimensions. Now, these dimensions can be described either like this as normals to like a bonding path in chemistry, or as tangents in a field type of representation. So in this picture I've gone with the normals, similar to in chemistry where there is a bond path being used. Now basically one of the things that we want to add is about this dark matter creation sequence. Matter has always existed. Eternity was started way before the Big Bang. The Big Bang occurred as expansion passed a certain threshold, and the protons and electrons became separated far enough to emit gamma rays. That ionized every pair in the universe, causing all protons and electrons to become unpaired, with electrons flying off in all directions to the far reaches of a tiny early universe at high speeds. This unpaired state is now dark matter. What happened then was that these electrons occasionally collided head-on with other electrons. That is where matter was created out of dark matter. These electrons that collided combined with the dark matter that is local to the Milky Way galaxy, forming the matter that makes us and the entire universe. There's an equal number of electrons and protons in the universe. The electrons that went out far into the distance are still there, receding away from us at a very high speed. And the electrons are in a huge diaspora, almost at the edge of our observable universe, and they form dark energy. So that there's an equal number of electrons and protons in the universe, but dark matter has no electrons and plenty of protons. And there's no repulsion between these protons, because without the electrons present, there's no Pauli exclusion principle. So thank you very much.